Hello and welcome to TidyX episode 72. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick. You can find TidyX on Twitter at tidy_explained. You can hit us up on Gmail, tidy.explained@gmail.com. You can like and subscribe on the YouTube channel or take out an issue in the GitHub repo.
All right, and those are the many ways you can get in contact with us. We really appreciate hearing from you all. In fact, last week I had a good conversation with somebody on YouTube about something that I'm actually going to bring up in a moment. But what are we doing this week, Patrick, as I go to share a screen so you know what we're talking about?
Yep, so we are continuing our work with databases. Last week we scraped a bunch of NBA data, 20 years worth of NBA team scoring data, and we talked about querying the tables, aggregating data, etc. within SQL, within R, R within SQL, either way. Today, what we're going to do is we're going to work on going from the database into R to output to Shiny for a user interactive dashboard. So basically, we're going to run a query and do the aggregations all within the server of R and then render a plot at the end of it, allowing the user to use the Shiny app and have some control over what the server is actually querying from the database. So that's what we're going to do today.
Yep, and we've talked a lot about the power of Shiny and what it does for us. It really allows us to put the power in the hands of our users and give them the ability to do it. It multiplies our impact on our organization because then we don't have to do everything for them. They have the ability to do that and explore the data and explore the questions they have, as long as we build our Shiny app correctly, which we'll have a simple one coming up. And we have a whole series on building a rather complicated Shiny app. Back in this was episodes 30, it was a while
30s,
ago.
maybe, yeah, exactly.
We talked
long time ago.
So you should definitely check that out. I'll put a link in the description below.
And we've done a ton of Shiny too on different things as well. So
exactly, Shiny is incredibly helpful. But let's get going. So first we're going to load the library Tidyverse, which somebody brought up. We always say it's for our data manipulation needs because it has a bunch of libraries under the hood that it's calling. So as you can see here, it's loading ggplot2, per, tibble, dplyr, tidyr, stringr, readr, forcats, like that. Those are a lot of the packages you're going to be using for your data manipulation and plotting needs. So it does that, and then it also lets you know some conflicts. So hey, I've got dplyr filter, which overrides the default filter function in R, as well as lag overrides the default lag function in R. So this function, or this is like a shortcut for loading a bunch of libraries and loading them in the right way, because dplyr and plyr have conflicts. So there. And then there's also an interesting thing, and I have a note here. We call library dplyr explicitly because we want some of the functions that exist in dplyr, but somebody else brought up that the tbl function is technically from dplyr, not dbplyr, and that is correct. And you can technically not load dbplyr and still interact with your databases because it's loading it under the hood. So I just wanted to admit I was wrong. We were wrong when we were saying that dplyr gives us the tbl function, and that no, it's actually from dplyr, and I will admit when I'm wrong. So, all right, stepping forward, now we're loading our SQLite and DBI in order to connect with our databases and interact with them. And then we're going to load Shiny and Shiny widgets so that we can make our Shiny app. All right, Patrick, you want to take us through this first set here?
Yep. So we'll walk through kind of the nitty gritty of how we're going to get the data out first, and then we're going to kind of plop this all into a Shiny server. So the first thing, as we've done before, is you need to be able to establish a database connection if you want to access the tables that are stored within your database. So we set up our DB connection, dbcon, using the dbconnect function. We set the driver, and then we establish where that database is so that we can connect directly to it. In this case, it is part of the Tidy Tuesday Explained folder there. So
Good.
we'll go ahead and set that up.
Right, so now we're connected.
So we've got yep, there we go. We're good to go. And as always, we can take a peek at what tables are available to us using the DB list tables. So we see that we have seasonal data from 2001 to 2002. If you want to see the head of some of those tables, last week we talk all about exploring the tables and things like that. So that would be worth checking out. The next thing that we need to do is we need to get the data that we'll want for our Shiny app. So we're going to build a Shiny app that's going to plot the home scoring margin for any team that the user selects over the 2001 to 2020 season periods. So we're going to just show you how we kind of do that here. It's a small little map DFR. So we're using the map DFR functions to turn this into a data frame. We're going to paste season. This is just a smaller one. It's season 2001 to 2005, so that we don't do the full thing. And then we're going to, as always, map DFR is going to take a function as the second argument. So the function there is going to be taking each season. We're going to use the table function to connect to the database and extract out that season. This case, we're going to filter out the home team when it is equal to the Los Angeles Lakers. So they're going to be the team that we're interested in. We're going to select the columns of need. And then we're going to, I don't think, do we need as data frame there? If it's map DFR, we might not need as.
Let's see.
Boom.
Nope. It's got to be converted into a data frame because I think technically it's a lazy data frame or a SQL table or something like that.
It's called a lazy query, I believe. Mm-hmm. Yeah. So go ahead and run that. And we're good. And boom. So there we go. We have home and visitor. This is the Lakers. You could see to the left there a identifier for each left column for identifier for each game. So it's going to be year and then underscore some sort of unique number that's either coming from Basketball Reference or the NBA itself. That's going to be important for us because we're going to parse out those first four digits to turn them into a season so that we can get a time series plot. So that is how we're going to grab the data for our Shiny app. So let's proceed forward. Now that we've kind of gone through that, let's proceed forward with building the Shiny app.
All right. So let me quickly disconnect from this. We forgot to put in the DB disconnect. I always like to, it doesn't cost you much, at least in my opinion, to connect and disconnect from it just to make sure your connections are always clean. And that way you don't have just random connections lying around to your database because it can slow down. You get weird errors and weird messages periodically if you leave them open. So just close them.
I think they default closed after a certain period of time, don't they?
They probably do.
Yeah.
I mean, I know I get warnings from them going, "Hey, this has been open for a while. I'm closing it."
Yeah.
It's like, oh, okay, I'm sorry. All right, so now we connected again to the database, and now we want to figure out what are the teams that actually existed from 2001 to 2020, because we are from Seattle. Well, I am from Seattle originally, and we had the Seattle Supersonics with us for a while, but they got sold in 2008, or at some point around then, back when I was in high school, and they moved to Oklahoma. So if you only grabbed one season, you might not get all the teams that actually exist. And so I wanted to write a query that would identify what are the total set of optional teams that exist inside of this data set. And so I couldn't think of a way to do it with dbplyr or dplyr, a function using that. So I wrote a SQL query, but because we're using dbgetQuery, it accepts a string, so I could be really lazy with what I actually write to then actually generate that full query. And so what I'm doing here is, this is a pretty basic, I don't want to use basic because that implies that it's not complicated. I'm going to be selecting the home team from each season, from 2001 to 2020. I'm going to use the paste function to put these together. So then we would end up, if we just ran this, with 20 different select statements. But that means that I'd have to call this 20 times and then pull it all together. Well, SQL has a really interesting function called union, which behaves very similarly to it's like the mathematical union. When if you take two different vectors and you take a union, it's going to give you the set of unique values that exist across those two vectors. We can do the same thing here. And so I'm going to use this collapse argument inside of paste, which will then put that string in between every single one of these and put it together into a single call. So we can do this. So that's one long string that's saying select home from season 2001, then union that with select home season from 2002, blah, 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 all the way to 2020. So when we run this, we get all the teams that have existed from 2001 to 2020. There we go. Yeah. I blocked that year out temporarily in my head. So now we have the complete set of teams that exist. That means that we can go to actually build our Shiny app to then allow us to kind of explore scoring margin over the years. So this is, okay, here we are. So now we are Shiny app. Sorry, that's a little small there. So I'll talk about the UI if you want to talk about the server, or do you want to flip that?
Either way, it doesn't matter to me. Go for it.
All right. So with the Shiny app, you have the UI and you have the backend server side of things. The UI is defined as HTML essentially under the hood. So first we use fluid page, which is going to define, hey, we're going to have a page that is fluid, which means things can kind of float around in there when we change the size of it. It has the argument title, and we're going to tell that what the title of our Shiny app is, and this is home scoring margin from 2001 to 2020. And then we have two different panels that'll move around. There's the sidebar panel and the main panel. In the sidebar panel, which is something that shows up, surprise, surprise, on the left side, and it's got a default size there, we can start populating it with things. In this Shiny app, we only want it to be the user to be able to select which team they care about. And so we're going to use this picker input function from Shiny Widgets. It has an input ID, which is home, the label, which is what gets displayed above the picker here, and we say, hey, pick a team. The choices is the complete set of teams that we just calculated. Multiple equals true, which means that they can select as many teams as they want. And then we are going to, by default, have the Cleveland Cavaliers selected. We could also set it to null, meaning it won't have anyone selected, but this way, when somebody brings up a Shiny app, it'll automatically have it populated with a team. And then on the main panel, which will be, the bigger main panel on the right, we're going to have a plot output, and that output ID is going to be PLT. So this is our plot is going to fill up the main panel on the right, and on the left-hand side will be the picker where you can select any number of teams that have existed from 2001 to 2020. And that is our UI interface. Now we have to have the server, which is the logic on the back end, and go, Patrick.
All right, here we go. Server, and it's going to be a function that takes an input and delivers us an output. So first thing we do is we need to get the data. So we're going to set up this reactive. We're going to call it SQL DAT. It's going to require that there's an input from the UI input home, which there always is because we set a default to the Cleveland Cavaliers. So that's not going to be a problem. But if we did set it to null, this would be useful because then you don't get like this ugly warning on the Shiny app when the user uses, it'll just be blank. But we set it there just for good measure. All right. So within our reactive, we're going to connect to our database the same way we did up above. And then we're going to say on exit. So once we're done with this reactive function on exit, just go ahead and drop that connection. So like Ella said, we don't have all kinds of connections floating around. So we're going to connect to our database. Then we're going to set up a thing that says when we exit this function, drop the connection. We're going to write the query for the database. We did this up above. It's using map DFR. This time we're going to go all the way from 2001 to 2020. And then in the filter, instead of where we had home equals Los Angeles Lakers up above, we're going to do home in is the input of home. So basically, the user is saying which home team they're interested in, and they can select multiple. So they do have the option. So that's why we have to use the little in argument there in there. The 2 exclamation points were something that was specific to, I think, the fact that this was a database and not a normal just data frame like we would use maybe in previous shinies.
Yeah, it's because it's a reactive and this is a shiny input. And so there's some behavior around shiny. And so actually shiny gave a really nice warning or error message telling us to do this.
Yeah.
So we'll trust Winston
We trust
Chang,
it works.
and
We trust
we'll
it
trust
works.
the studio folks so that they know what they're talking about, and
Yeah.
this is what we should be doing.
Yeah. We select our columns of interest, we turn it into a data frame, and now we have our SQL DAT, which allows us to move to our next reactive. So the first reactive is saying, hey, the user told us to do something, go ahead and grab that data that they want. The next reactive is basically converting this into the data that we need for our plot. So we're going to take that reactive SQL DAT. That's why it's written as a function there. It's SQL DAT with brackets or with parentheses. So it's written as a function, but it is a data frame. We're going to do a little bit of mutation here. So like I said, that left-hand column was a unique identifier for each game. We're going to substring out the first 4 variables, or the first 4 elements within that vector, which is the year, right? So it's 2001 to 2021. And then we're going to group by home and season, and we're going to create our home points margin of victory, which is going to be the average of the home points minus the visitor points. And we return that, and now we have a reactive DAT data frame, which is taking the reactive SQL data and turning it into the data frame that we'll need to create our output $PLT. So now we're ready to plot our output. We're going to render the plot. Again, DAT is a data frame, but it is reactive, so we need to, you treat it like a function. So we give it the parentheses there. We're going to go into, this is straight up ggplot that we've done a million times. On the x-axis, we're going to have season, so it's going to be a time series plot. On the y-axis, we've got that point margin that we created when we built the DAT data frame. We're going to color this by home, and then we throw that group in by home so that it knows to plot separate lines for each of the home teams that the user has specified interest in. We run some labels here, so we're going to just give it a title that defines what we're looking at. And obviously the y-axis will be the home stadium point differential, and the x-axis the season. I guess in reality, the 2020 season wouldn't have a home stadium point differential because nobody was a home team. They played in a bubble, but we'll overlook that for now.
Details.
We're going to set a geohome H line for some context to 0, basically meaning that you are a zeroed out team at home. So we'll set that for context. We're going to set a geohm line. So this is going to be a line plot for the home point margin over time. We're also going to set the points to be a shape of 21. So that's going to be an empty point. It's going to have a circle around it, empty point. We're going to fill it with a white, and we're going to make it size 5. So basically the circle around the empty point, or the white filled point, is going to be the color of the line for whatever teams the user has selected. We're going to set theme to classic, which basically removes all grid line. It just gives us a nice, clean, classic white plot. And so that's it. That's a pretty simple server. And when we go ahead and we run the UI in the server, we can output this to a Shiny app, and it ends up looking like this, where we're looking at, remember, the Cleveland Cavs were the defaulted team. So you can get a sense for the LeBron years pretty clearly right there. It's like, okay, he was there, then he left, then he came back, and they won a championship. So they're either they're like a make or break. LeBron is a make or break for that team. They're either really good or bad. Golden State, obviously, you have the kind of the Steph Curry, Splash Brothers years where they were scoring a ton of points. And this is pretty cool. We could have put a plot at the bottom, like that was basically the same teams away. We could have selected their away margin and
shown that as well.
Yeah. But so I like the example though of the Seattle Supersonics moving to Houston. So hey, that's a good right there without the plot, without anything selected. So that was the reason why you require the input. See how it's blank. If we didn't do that, it would have an error saying no data or something like that.
Invalid query or whatever.
Invalid query. Yeah, exactly. So here's the Supersonics, and then you can see where OKC took over. So there it is. They left in. They were kind of on this downtrend from 2005 to 2008. Team left. Come in 2009. They draft Kevin Durant, and then that team also had Westbrook and Harden. They were a real juggernaut. Unfortunately, a team that never won the championship, but they were like incredibly dominant at times, and you could see their home point margin there. Yeah. Other things we could have done to make this like a bit nicer was we could have set the y-axis to a specific limit, like maybe -20 to +20, because as of right now, depending on who you select, it's going to dance a little bit. So there it went down to -10 to accommodate the Chicago Bulls. I don't know if there's any teams that are like outside of 10. That would be pretty bad.
He really tanked lately.
Like really, like a really horrible team. I can't think of anyone. The cool thing about this picker on the left-hand side that Ellis is using, and why I used it instead of select input. We've often done select input. Select input works just fine for this type of thing. I love the picker because you let the user click on things, and there's a argument within the picker that you could set at the bottom that says select all or deselect all by default. So you could actually clear it if you wanted, select everybody if you wanted. So the picker is kind of a fun little
and I think you can also add like little icons and like you can really make this really really fun.
Yeah, so I kind of like the picker when I can use it. I think it's an interesting one.
Yeah. Apparently, there's no information for the Charlotte Hornets from.
Oh, that's interesting because they were a team. They were a team that moved, weren't they? The Hornets, then they were the Pelicans, then they were the Bobcats, something like that. Was
Bobcats.
They were.
Yeah, let's unselect everyone else. Sorry, we're going down a bit of a tangent here. You can ignore. Yeah, there we go. It is Hornets, Bobcats, Hornets.
Yeah. So I don't. Yeah. Interesting.
I don't know.
But that's just a fun way of interacting with your SQL database, allowing your user to interact with your SQL database. You basically write all the stuff under the hood in the background, and they have the opportunity to sort of query your database without having to write a query.
Without actually having to know. And doing it this way also protects you from any SQL injection or anything like that, which is a totally other world of things that we won't get into yet. But thank you all so much for joining us. I think we're going to call it right here. So, as always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick. Both of us are on Twitter, Tidy_explained. It's at Tidy_explained. You can hit us up on Gmail, tidy.explained@gmail. You can open up an issue on the GitHub repo if there's something that you'd like to see in future episodes or have us do a small series on. We can certainly do that. So feel free to hit us up on the repo, open an issue, or as probably the most frequent way that people try and interact is like and subscribe on the YouTube channel and drop a comment underneath the video, and we can get moving from there.
Yes, just like that. Definitely subscribe, y'all. And keep on exploring your world.